Um, okay. Cool. Both Kwa and I have been on both sides of this, so we know how stressful the whole experience can be. So we're going to go through some tips and whatnot. We'll start by introducing ourselves.
Yeah, so thank you again, Dana, for the introduction. My name is Hua, and I am a senior software engineer at Mastercard Data and Services. And I've been with the company for a little bit under 2 years. I joined at the beginning of 2020. Prior to Mastercard, I spent about 4 years as one of the first engineers at Quorum, a public affairs software startup based in Washington, D.C. And then before that, I went to UC Berkeley, graduated in 2015 with a degree in computer science.
Cool. And I'm Guillermo. I'm also a senior software engineer at Mastercard. I've been with the company for a bit over 4 years. I've been on all sorts of different DevOps teams. And then I graduated from UPenn in 2017 with an MSc in scientific computing, and then in 2016 with a BSc in computer science. Cool. So first we wanted to just give you an overview of who we are and where we sit. So there's Mastercard as a whole. And then inside Mastercard, we have a division called Data and Services. And Data Services is this hybrid between sort of big data technology and the traditional strategy consulting. And so what we do here is build and engineer all sorts of different technology solutions that sort of help our customers sort of better understand their data and sort of better interact with their customers. And underneath that, there's a section called platforms, which is the engineering software section, and that's where we work. Cool. So the agenda for today, we'll start by talking about how technical interviews are structured and just a general format. Then we're going to go through a sample problem, and the way that we're going to do this is we'll do a hybrid of an interviewer and an interviewee and sort of highlight the things that the interviewer is looking for and the things that the interviewee should be trying to highlight. And we'll go through the problem as that. And then after we do that, particularly for the technical section, then we'll just talk about a little bit what happens after the interview. And then we'll give some tips on how to prepare for the interview. And then we'll have some time at the end for questions.
Sounds good. So as Guillermo mentioned, let's go over how technical interviews are typically structured. So duration-wise, technical interviews typically take about 45 minutes to an hour, depending on the round, the position that you're interviewing for, as well as the company that you're interviewing with. It typically starts with a quick introduction of the interviewer and the interviewee. Notice that there could be more than one interviewer in a particular round. And after the quick introduction, we typically go over your resume. So make sure that you feel comfortable discussing anything that you have on your resume, whether that is programming languages, technologies that you're familiar with, projects that you've been involved in. At Mastercard, we actually discuss the bulk of your resume in a separate behavioral interview. However, we expect to discuss anything on your resume at any point in either the behavioral round or the coding round. And then after the quick check about your previous experience on your resume, we go through the main coding question, which usually takes at least 30 minutes. And then finally, there is some time for Q&A for asking the interviewer about anything about their work, as well as the logistical next steps.
Cool. So with that in mind, here's the sample problem that we're going to go through. So you have a list of n+1 integers between 1 and n. There's going to be a duplicate, but there could be more than one. And then as an example, if you have n is equals to 3, then you might have a couple lists here. You might have 3, 1, 1, 3, or you might have 1, 3, 2, 2. And then the objective of the question is to print out one of the numbers that might appear more than once. And so this is basically all that we would give you as a sort of start question. Cool. So from the interviewer side, the type of questions, like the one that we just picked, tend to be general sort of breadth CS questions, just overall knowledge that you might have. Usually when we're looking at the resume, if we can, we might try to tailor the question towards that, or we might try to make the question a little fun and try to give it a little bit of context that might be related to the job that we do or whatnot. The main difference between sort of an intern and a junior full-time position is just that we expect you to have, done a bit more work. And so therefore we expect you to have a stronger CS fundamentals, but the questions aren't really changed dramatically. The question is usually purposely given so that it has very limited extra details. The goal there, of course, is that we want to see the interviewee sort of brainstorm the different requirements and ask type of questions, which is, how it works in the real world, where you just have a general question and you got to go figure out all the details.
Yeah, and then from the interviewee perspective, things that you should highlight, make clear the requirements, right? So from that initial question, you want to make sure, what kind of data structure can you use? Do you care about particular space complexity, time complexity, any particular requirement about the question that really stood out to you? Then once you feel comfortable with all the requirements and understand the question, talk with the interviewers through the potential answers that you have in mind. It is absolutely fine if your initial gut is a basic bare bone brute force solution, like something that is very, very basic that accomplish what the question is asking for. And then eventually we'll want to optimize the code, or we want to optimize the solution to arrive at something more, something that has better runtime, better space complexity, that are more optimized for what the question is asking for. As always, make sure to communicate with the interviewer throughout the whole process, and especially before jumping straight to coding. You don't want to, like right after the interviewer describes the question to you, to just jump straight into the coding software or the terminal or whatever to just start writing code. Make sure to always think through the question and spend some time discussing the requirements as well as anything that you can think of with the interviewer. Make sure to also walk through a couple examples. So for example, with the question that we were just given, we were given a couple of different examples, but if the interviewer didn't give you any example, then design your own examples. Think about the different edge cases, think about, the different things that can arise as you think through the different solutions. And then finally, one big tip that we have for you guys is make sure to pick a coding language that you feel most comfortable with, but it's also syntactically easy to write, or like easy to, for the interviewer to also understand. You don't want to, ideally, you don't want to choose something a little bit more syntactically verbose like Java or C++, because it means that you might need more setup code before you actually can tackle the main question. So you want to pick something that is easy, simple, easy to read, like Python, JavaScript, Ruby, but make sure that you also feel comfortable with it. Like, don't try something brand new during the technical interview.
I just wanted to stress the importance of making sure that you think about the question before you start coding. A very common problem that I see when I interview is that people just jump straight into the code, having fully thought it out, and then halfway through the code they figure out that there's something else that they need to do and they panic. So yeah.
Yeah, so as we just discussed, like thinking through the question before you start coding is very, very important. It is as important as the actual coding part itself. So going back to the example that we're given, right? So we can list out the requirements, or kind of like paraphrase the requirement in some way and making sure that you fully understand the problem before you start coding. So the requirement were, we were given n+1 integers between the range 1 and n, and we know that there have to be at least one duplicate based on the pigeonhole principle, right? Like there cannot be no duplicate whatsoever with this requirement. So with the two examples that the problem the interviewer gave us, right? So if n is equal to 3, we know that we would be given 4 integers or n plus 1, right? So then the input array, or like the example array or list here would be 3113, or it could be 1322, right? So then with that first example, we can notice visually that there are 2 duplicates, 3 and 1. But the question, what did the question ask us? The question asked to print out a duplicate. So then we then, like if you are an interviewee doing this question, you would then ask the interviewer, okay, so can I print out either 1 or 3? Are they both acceptable answers? And the answer in this case is yes, like we just need to print out any of the duplicates, right? But with the second example, 1322, then there's only one duplicate here, which is 2. So printing out anything other than 2 would be incorrect.
Cool. And so, once you figured that out, then it's time to actually start coding. So from the interviewer side, first thing that we're going to be looking for is computer science basics on the language of your choice. Here, I mean things like, for example, do you understand how to declare a hash set a dictionary? Can you write a good for loop? Do you understand how to print statements? Do you know how to do variable assigning? Do you understand the different types that the language might have, etc.? The interviewer will also be looking for your ability to communicate, being clear as to, as you're going through what you're trying to do, what your intent is, if you're getting stuck and you need help, etc., or if you're looking for feedback or not, assessing what's happening, etc. The interviewer will be trying to look for that type of thing. The sort of goal here, right, isn't, oh, can you do this perfect problem? Do you know this magical algorithm? The goal here is to try to understand how you approach a problem and how you go about solving it. The interviewer is going to generally be pretty quiet. We try to speak very little. The goal there isn't that we're not paying attention, but we want to give you as much room for you to, think of the solution, for you to communicate with us. And if you start asking questions or communicate or whatnot, then the interviewer will start engaging with you.
Yeah, and then from the interviewee perspective, once you have thought through the initial solution, make clear the requirements, communicate with the interviewer, it's time to write a code, right? So then when you're ready to write the very first version of the code, don't pay too much attention to any syntax errors or like variable name or like things that are typically not super important. As you write a code, make sure to communicate with the interviewer what you are doing, what you are thinking of, like why you want certain variable to exist, why you want to use this particular algorithm, why you want to break things into multiple functions. Are you going to, call one function from another, so on and so forth. And then finally, if you don't remember a particular syntax or a particular way of doing things in a language of your choice, don't worry too much about that, right? Like in the real world, we don't expect you to fully know everything off the top of your head. Software engineers do use things like Google, Stack Overflow to look up things. So if you don't remember a particular thing, just describe to the interviewer what that particular thing is supposed to do. Do it to the best of your ability, and we'll happily show you how to do it if we happen to know the language well, or we can also play along and just think of it as pseudocode, right? So an example would be, let's say you want to declare, let's say like a set in Python, but you don't remember exactly what the syntax for that is. You remember vaguely that it's some curly braces, it's some dictionary, but you don't remember exactly what the set is. You can describe that to the interviewer. If the interviewer know what that is, they will be happy to help you with that. Otherwise, they'll be happy to just accept that you declare a set, right? So don't sweat too much about don't get too hung up about a particular syntax or a particular way of doing things. that will most likely happen, especially when you are coding under time pressure and when someone is also watching you. So it's totally okay when that happens. Just making sure that you communicate that with the interviewer, and then we can all move on. Yeah, so going back to the example that were given. So a potential brute force solution, right? Like something very, very basic that you can think of to solve that question is something along the line of using two for loops, looping through the input array, and then compare every number against every other number. And if there's a matching pair, then we know that that has to be the duplicate, right? That is likely the simplest and like the most brute force solution you can think of to solve the question. And this solution, for those that have taken data structures and algo, you know that its solution is going to be quadratic in runtime because you are using two for loops and you're looping through everything pairwise, right? And then but then, because it's a brute force solution, right? Likely that there's going to be a better way to solve the question, right? So you can think about this and you can brainstorm. Okay, so we used two for loops. We didn't quite use any extra space or any data structures that would help us, record whether the number has appeared before or how we can find the duplicate easier. So then if we think about it that way, right? So what if there is a data structure that would let us record whether a number has appeared before, so we can know if we come across it again that it has to be a duplicate. Well, turns out there is exactly a data structure that is designed for that, and it is a hash set, right? So with a hash set, once you have seen something before, you will know that you have come across a duplicate. So using that additional data structure, you can now reduce the runtime complexity to simply be O of n or just linear, but you also incur O of n in terms of space. So let's go through the code for what that looks like. So the potential, one potential way of doing that with that set solution, it looks like this in Python. So you declare a set, an empty set, and then for every item in the input array or the input list in Python, if you have not come across the item before, you simply add that to the set, and then otherwise, which means that you have come across it before, you know that it has to be a duplicate, so you print out the item as requested by the problem, and then you break out the for loop. And as you can see here, this solution takes linear in runtime and also takes linear O of n in space complexity as well. So we have effectively optimized our brute force quadratic solution.
Cool. So, that's going to be sort of the initial part of the interview. The interviewer usually will then ask you about runtime and space complexity. I encourage everybody to refresh their knowledge on that if they haven't. This type of thing will be like, I'm going to ask you, oh, what's the runtime of this? Do you think that this can be done better or faster or not? In this particular case, for example, you can't really go any faster than linear. But you might be able to do better in space. And then we'll talk about any type of edge cases that might be missed or weren't covered in the initial solution, And then after that, what we're going to do is then we'll start adding extra constraints to the original question. The goal here is to try to see how you act when you need to refactor your code, when you need to sort of take a step back and relook at it. And so we'll see your general sort of view on this. We'll see how you can approach the problem from a different way and whatnot.
Yeah, and then from the interviewee perspective, if you haven't already, after your initial working solution, discuss the space-time complexity with the interviewer, any trade-off that you make, discuss the potential edge cases with respect to this problem. I would say that with the particular problem that we're using here, there's not that many edge cases, but with other problems, there might be some potential edge cases or like things that you can, write an if condition that would help you break out earlier, so on and so forth. And then, as Guillermo mentioned, as additional constraints arise, it is absolutely fine to take a step back and then approach the question as if it is a brand new question. One of the things that we notice when we interview candidates is that a lot of the time, the candidate got stuck on their initial working solution and try to optimize that further, as opposed to taking a step back and restart everything from scratch and then look at the question with a completely brand new mindset, right? Like you oftentimes your initial solution will no longer be applicable. So if you found that it is very difficult to optimize that initial solution further or to modify it, just stretch it all together and then just restart from scratch and then think about the question with the additional constraint as if it's a brand new question.
Cool. So back to our example, in an original version, we didn't make any restrictions in terms of time or space complexity. But let's suppose that we do, and we say, you can't use any extra space, which means big O of n. Your original brute source solution worked, but the problem that it has is that it's not optimized, right? And so what we want to do here is, come up with a different solution. One approach here to do it is to sort. We want to sort in memory, which means we want to use one of the various different sorting algorithms that will sort in place. Good examples here will be quicksort and heap sort. And then we then just, after we've sorted the algorithm, we then just run through and we find a adjacent pair. And then, that's our first duplicate. Sorting will take n log n, total runtime. And then, comparing through the adjacent pairs will take big O of n. And therefore, your overall runtime will be n log n. So let's take a look at the code. Here, version 2 of the algorithm, we grab it, we sort it. Quick note here, for those that might know, Python uses timsort for sorting. Timsort is not an in-place sorting algorithm. It actually has a space complexity of big O of n. But this is the classical type of question that you would highlight to the interviewer if you were aware of this and just say, like we would either import some other sorting algorithm that does this for us, or if it was a real thing, we would actually implement the sorting algorithm. Nobody's going to ask you to implement a textbook sorting algorithm. We know you can. That's not something people regularly do. But after you've sorted it, then we just then iterate through it, and then we take a look at the two pairs, and then find the first one.
Cool. All right. So as an example, what if you solve you solve the basic question, you solve the additional constraint that requires you to use no extra space, right? What if like there's still time, and then like the interviewer wants to throw an additional curve into the question. So for our particular example, what if not only we're not allowed to use any extra space, we are also not allowed to modify the original input array. So the solution previously that Guillermo described that requires you to sort the array in memory will no longer apply, right? So now you can't use any extra space. It has to be all of one, and you can not also modify the input array. But we still want that O of n log n runtime. So if you get stuck with the initial two solutions or try to optimize those, you will likely not getting to the actual solution here, right? Because none of those satisfy these requirements. So taking a complete step back and approaching this question in brand new light, we know that O of n log n runtime means that we need to do O of n work, or like linear work with the log n levels, right? Log n times of doing it. the reverse cannot be true. Like you cannot do log n work in n times because you have to look at everything in the array, or like in the input list array, right? So then looking through everything by default is going to be linear work. So then it comes to the log n level. So what exactly is the log n level? So for those that have taken algorithm, you might remember a particular algorithmic strategy called divide and conquer. So in particular here, something that would help us with the log n levels is something like binary search, when we cut down our problem space by half every time. So you think through that and you think, okay, binary search, we know that it works on a sorted array. However, our input array is not sorted, right? The example was 1331 or like 1322, something like that. So the input array is definitely not sorted, and we are not allowed to modify the original input array whatsoever due to this new requirement. So, however, what else is given to us that is pre-sorted, that comes sorted already? Well, the range, right? We know that there are n+1 integers between the range 1 and n. This is why, like, paraphrasing the requirements is actually often very helpful, because there actually are hints in the question, or there are ways to think through the question with the additional constraints if you look carefully at all the parts of the question. So given that we know that the range 1 to n come pre-sorted, we can go through the list and we can count the number of integers between the range 1 to n divided by 2. If the count is greater than the number of possible integers in that range, which is n divided by 2, we know that there has to be a duplicate in that range due to the pigeonhole principle, right? There cannot be, let's say, 5 integers in the range 1 to 4 without a duplicate in that range. There has to be one repeat numbers, at least one repeat numbers, right? So if we count up the number in that range and we saw that the number of possible integers in that range is smaller than the actual number of integers, then the duplicate has to be in that range. Otherwise, the duplicate has to exist in the other range, right? So we effectively are cutting the problem space in half, and going through the array in this way will give us that log n levels, right? So once we know which half of the range the duplicate is potentially in, we can then recurse the problem. You apply recursion here, and then keep doing that for the next half, the next half, the next half, and so on, until we found a duplicate number where the range is exactly just one number, right? When the range is at exactly one number, you know that the duplicate has to be that number. The time complexity here is going to be O of n log n, because going through the input array and counting everything, that is the O of n part, and then the log n part is achieved by the fact that we are cutting the array in half every time and doing log n levels of work. And then the space complexity is going to be O of 1, because we are not using any additional data structure. So I know there's a good chance this is going to be confusing. So let's go through the actual code. So this is what the code looks like for this particular additional constraint, right? So we declare the floor, which is the lower range, and then the ceiling for like the range n is going to be the length of the list minus 1 to avoid out-of-bound exception, right? So while the floor and the ceiling has not converged, we will divide our range, our pre-sorted 1 to n range, into a upper range and a lower range, right? And so we compute a few variables, including the midpoint, the lower range, lower bound and upper bound, as well as the upper range, lower bound and upper bound. Then, as we described in this algorithm over here, we go through and count the number of items in the lower range. If a particular item is in the lower range, we add that to the count. And then finally, we count up, or like we compute the number of distinct possible integer in that range. Once we have the number, we then do some simple comparison. If the number of items in the lower range is more than the number of distinct possible integers in that range, then there has to be a duplicate in that lower range, right? Otherwise, we know that the duplicate has to be in the upper range. So then we recompute the floor and ceiling. And then based on this while condition right here, when the floor and the ceiling hasn't converged yet, we'll keep recurse until the floor matches the ceiling, at which point that is our duplicate. So we print out the number. And then, so after the technical interview, so that is, like the 3 possible solutions. And I just wanted to quickly also highlight that chances are the interview are going to end on a slightly more difficult variation, like the one that you just see. Chances are the interviewer will come prepared with a question with multiple parts, because we don't want to run out of things to talk about, right? Like if you happen to solve the first 2 solutions pretty easily, chances are, we'll have an additional part that we want you to solve. And there's a good chance that you also will run out of time doing the last part, because quite frankly, the last part is pretty complicated. We don't fully expect, as interviewers, we actually don't fully expect interviewees to fully solve this last part of the question. But ideally, you would think about the ways to do it, as well as discuss through with the interviewer how you would approach this, and then start writing some pseudocode. Coming up with the fully working code for all 3 possible variations of this question in roughly 30 to 45 minutes is going to be close to impossible. Let's just say that. So, like, don't sweat it if you happen to just not going through the last solution or don't finish up the solution in time. If we cut you off, that's because we are running out of time. It's not because like you didn't get the question right and we want to move on. So yeah, so after the technical interview, typically there'll be like about 5 to 10 minutes at the end when you can ask the interviewers any questions about the interview itself, also about their work, about their team, about their most recent projects, so on and so forth. You should ideally already have a couple questions in the back of your mind. Don't try to come up with brand new questions on the spot, or like think of things that you've never asked anyone before. So think about a couple of questions that you want to know about the company, about the interviewer, about the interview itself, as well as the logistical next steps, right? Like if it's a phone interview, ask like how many rounds do you have left. If it's a on-site or like final round interview, ask how many interviews are like in your day. If it's the first round of the day, or ask like how like when can you expect to hear back with regard to the next steps. And then so this is a slide that Guillermo and I have prepared for you guys on the best ways to prepare for technical interviews. So here are a few tips. The first thing is make sure to be comfortable with data structures and algorithms. In particular, review the coursework, the material that you might have already taken or are currently taking. Make sure to be comfortable with the basics of computer science, things like arrays, linked lists, hash table, how to write for loops or while loops, object-oriented programming, recursion, as well as the space-time complexity and trade-off. Make sure to be comfortable discussing big O of n, and like think about all the different ways that you can trade off time and space, similar to the question that we just used, right? So the brute force solution that use O of n squared in quadratic and runtime, if we introduce the additional space or additional hash table or hash set solution, we can cut down the time to O of n, but then we incur the extra space complexity. So think about that trade-off. That's one of the classic computer science / software engineering / technical interview things that will come up. And then make sure to practice a ton of technical questions. Like practice makes perfect, right? So you can't expect to go into a technical interview having never done any of these questions before and come out on top, right? So some good resources that Guillermo and I have personally used in the past or know that people have used successfully in the past are LeetCode, which is a service that have a ton of technical questions that you can try solving, as well as a book by the name of Cracking the Coding Interview. Those two are the standard for good coding interview resources. There are definitely a lot more out there, but if you go through these two, you probably will be in a very, very solid position. Another thing with regard to practice is make sure to practice the question out loud. Like don't just start writing the code, because if you keep up that habit of just see the question, write the code, you are not going to do well in technical interviews, right? So make sure that you are doing some mock interviews by getting some friends to be your interviewers. Make sure to be comfortable talking out loud. Make sure to discuss it with your interviewer, with your friend. It's just like you are actually doing an interview, right? So talk out loud, talk while you write code. That's gonna be a very, very key point in being successful at technical interviews. And then as far as your resume goes, we briefly mentioned it at the how technical interview are structured slides, but make sure that you know your resume very well and be comfortable talking about anything that you listed on there. For example, if let's say you list Rust as a programming language that you feel very comfortable about, make sure you actually know Rust, right? Like don't list things for the sake of listing things. You don't want to be like you don't want your resume to be full of technical jargons that you actually do not understand. You want to be able to talk about anything and everything that appears on your resume, as well as comparing and contrasting different things, projects, or experience that you have had. And then one final tip is make sure to research the company you are interviewing for well. Know the company, know the position. If necessary, know the interviewer on LinkedIn, right? It doesn't hurt to do all these extra research steps. It just makes you feel like you are well informed and you actually care about the position you're interviewing for, and you are excited about the role, about the company, about the work that you will be doing. And that's it. That is everything that Guillermo and I have for you guys today. So we finished about 5 minutes earlier than we have thought. So we will have more time for Q&A.
And I'll encourage students just to come off mute and ask questions when you're ready.
We do have one question that is written. Says exactly what do you mean by CS fundamentals, software lifecycle? No, as Kwa alluded to in that very last slide, it's more around just like algorithms, data structures, and that type of thing. Generally, we don't expect people to be super familiar with the software lifecycles, and that's something you wouldn't see until you're working in the industry. So if you do know it, is obviously a plus.
Hi, my name is Alex. I have a quick question. So when you're in the interview and doing the technical part, is like running the code something that happens and like you can like maybe print things and do debugging or stuff, or is it just like you talk with the interview and you just code and just look at the like what you coded?
I can take it. I have never been or heard of an interview where they actually make you run code. It's mostly pseudocode, so I wouldn't worry too much about that. Yeah. Usually like the interviews that I do now that we're remote, like I'll ask you to just open like a blank notepad and then just type it there. No syntax highlighting, nothing. Yeah. And then, when they were in person, I would, just write them in a piece of paper in the notebook or in the whiteboard. You can't run that code, right?
Okay, thank you.
I will add that it is possible. I have definitely had interview where the interviewers ask me to run the code and expect me to write like syntactically compile code and all that. I would say those are very rare and few in between. And most of the time, those would be taking place in a online collaboration somewhere like coding tool, like CoderPad or CoderByte, or like some of those tools where you can actually run the code and then see the output in the terminal just to make sure that everything is correct. It actually can be one way to help you debug your code and figure out if anything is not working as expected. Although I would say I agree with Guillermo that as interviewers, we're not looking for the perfect code. We know you cannot write perfect code in 30 minutes. We can't either. So, we're looking for pseudocode. We're looking for your thought process. We're looking for how you approach the question, as opposed to writing syntactically perfect code and using, more than one letter variable and any of that stuff.
All right, thank you. That helps a lot.
I actually had a quick question. When you were talking through just the setup of the problem, like after you got the problem from the interviewer and you were kind of thinking about how to set it up, do you talk through that process too? Like there was a slide where you showed kind of the 4, the 3, 1, 1, 3. Like, are you kind of talking out loud and making notes kind of to give yourself a visual of how it might actually work before you start to code?
Yes, that's super important. This is a relatively simple question, but there could be some other scenario or some other type of example or edge case that isn't covered in the initial example that we give you. And so you might want to but what about these groups of numbers? In Qua's example, he was using the floor and assuming that all the numbers are positive integers. They don't necessarily have to be. That's an example. We could have something like 0 or something like that might break stuff. And so, thinking about that type of example, thinking about what those edge cases look like and what works and what doesn't work is very important. And
yeah, I would also add that if you are doing this interview at home, it might actually be really helpful if you have a piece of paper and a pen to just write down this example as you talk through with the interviewer about the examples. And it's like thinking through things is easier when you have a piece of paper and a pen, as opposed to try to think through things in your head, or typing things out or that kind of stuff. It can be really tricky doing that while also try to talk to the interviewer and I focus on maintaining eye contact and so on and so forth, right? So have a piece of paper, write out the example. If it's something more complicated, let's say a graph or something, draw it out. Draw it out, visualize it, see what it looks like, see if the example makes sense, see if there's any edge cases. Those kind of stuff will help you and get you very far. And then and then as Guillermo mentioned, right, with this particular problem, there is not that many or really any edge cases. But however, if let's say you solve the first 3 part really quickly for whatever reason, there are honestly a ton of additional constraints that we can throw into this one question. Things like having negative integers, right? Thing will certainly break. Or let's say bring out all the different duplicates, right? All of them instead of just one, right? Then which of your solution might still work, right? The things can get really complicated really quickly. So you definitely write things out, go through the examples, and then it actually is helpful to go through the example for every variation of the question as well, again and again, just to make sure that it still works as you expected it to.
Great, thanks.
Oh, I noticed, I don't know if it's been mentioned before, but I noticed that we're recording this. I was just wondering if if you are providing the recording of this as well as like the slide set?
Yes, both will be provided to students.
Okay.
So, as you guys are preparing interviews right now, what format are you guys using, and how has it like changed with like COVID? Like, is it like screen sharing or right now, and how is it different from like when you guys were doing it like face to face?
So there's two sides to that question. The first one is more like the general format that we use. We tend to break our interviews in behavioral interviews and just technical interviews. That way we can separate people and whatnot. So hopefully that answers the first part. Depending for the position that you're applying to, there's a different number of rounds. They're all happening remotely right now. And then the second part of your question on how it's changed. So the main thing that has changed is, like where you're writing the code. It used to be the case that, we'd either drive or fly to wherever you were, go to UVA and whatnot, and we'd sit in a room and ask you questions, and you'd do it in the whiteboard. And then for a final round, then you would come into our office, would show you the office, and then do it in the whiteboard again. Obviously, that can't be done now, so all of them are done virtually. And then we'll share your screen, ask you to open Notepad, and then you can write some code there, talk through it, etc. Draw if you want to draw, whatever you want to use.
Yeah.
Thank you.
Yep. I would also add that, like, because we're doing everything remotely and, electronically these days, make sure to sort out any potential technical difficulties in advance, right? Like, don't join, let's say, like a Zoom meeting with the interviewer like late, or like, when your headset is not working, or when your mute button is not working, or like, whatever reason, right? Or like, and then like shut up everything else. Like, don't look at your iMessages on one tab and then do the interview in another. It's like the very basic stuff, because like you only have that 30, 45 minutes, an hour to like make a really strong impression and to solve the question and to do everything, right? And time goes by really quickly. So definitely like make sure that you feel comfortable with your setup. Make sure that you have everything in advance, and like give yourself like that extra 10, 15 minutes before the interview. If you happen to do multiple interviews, like don't do them back to back, like don't schedule them like 3 to 4 and then 4 to 5. Let's say if something runs late, like with one company, like you're gonna be late to the other one, and you could potentially like ruin both. So like space things out wisely, and make sure to give yourself time to take a break. Like don't stress out too much, but also be well prepared, right? Like that will get you very far in general.
For a lot of these quirks, my strongest advice there is just do mock interviews with each other and whatnot. Like your friends will be able to tell, like, hey, you're distracted, hey, you're looking at your phone, etc. Like that's how I've always done it, and it worked out.
I have one more question. I think sometimes one of the biggest fears of students is that they get into an interview and just get stuck and can't think through what the answer might be. Do either of you have any advice for if you just kind of have a moment where you feel like you can't get yourself moving forward with a question?
Mm-hmm. So that's happened to both me and people that I've interviewed. My advice here is, number one, keep talking. Make sure that you're going through, like your brain is running. Make sure that the interviewer is hearing what you're thinking about and the different options, even if you're stuck. If you just stay quiet, I can't help you. I can't give you hints. I can't push you in the right direction. I don't know what's going on through your mind. So, make sure that you're communicating constantly. And then my second advice there is, take a deep breath, go back to the beginning, try to look at the problem, see why you're getting stuck, what's happening that isn't working, and talk about it. The interviewer will most likely than not try to push you in the right direction. The idea here is that they're not just giving you the answer, they're trying to hint you into the solution. Like, have you considered this, or have you considered this other thing, or like, have you thought about this, especially if you have some sort of diagram or some sort of drawing, or you're talking about particular code or particular concept that you have, to try to push you in the right direction. So keep talking and, take a deep breath, go back to wherever you need to do.
Great, thanks. One more question from Alex.
Is it okay to explicitly ask the interviewer, like, if you're stuck, like, for a hint? Is that a bad thing? Or should you like keep explaining yourself until they kind of push you in that direction?
The phrasing there is all that matters. Straight up saying, can I get a hint because I don't understand? Not great. Definitely no. But like, for example, like explaining, like in one of our examples, like, okay, I'm thinking, like when we were talking about like, oh, don't use the space-time complexity, or like, okay, I'm thinking maybe some sort of sorting algorithm, but like something like merge sort uses like n space, and so like that doesn't work. So, try to that type of process. And so like what I'm gonna hint you at, like, have you considered like, other sorting algorithms that perhaps don't use as much space or something like that? Or, you might know that, like the sorting algorithm in Python doesn't like uses too much space, and so you're like, but that doesn't really work. And then so like, but like you're in the right general direction. And so like sort of justifying and like acknowledging like, but here this doesn't work, or here I'm stuck, or this doesn't work correctly. Like that type of thing might push you in the better direction of the person giving you the hint, rather than just straight up saying like, I need help. That's how I would phrase it. Yeah.
Any other questions from anyone? I guess I haven't checked the chat. I don't see anything there. All right. Well, I think this has been a huge help. And I can't express enough how grateful we are to have you take time out of your day to walk through this with everyone. We're so thankful that we have great partners like Mastercard that will help us out. So we really appreciate all of that you've told us here today. And I know that it's going to help students with their next interviews and make it a little less stressful for them. So any final questions from anyone before we close out the session? All right. Well, thank you again, Guillermo and Qua. We really appreciate it, and look forward to maybe seeing you again virtually, or maybe on someday back on grounds here at UVA for some recruiting. But we really appreciate all your time and all your wisdom, and are super thankful to have you here with us tonight.